Students, welcome to the subject software engineering. At present, we are studying chapter number 9, that is design engineering. And today's topic is design concepts. Students, we have been studying these design concepts since last two periods. So this is the third period. Okay. So these design concepts are very important, okay, from software development point of view. That is why we are taking more time on this. Earlier, we have studied the two concepts, that is the abstraction and architecture. Today, we will study three more concepts, that is pattern, modularity and information hiding. In remaining concepts such as functional independence, refinements, refactoring, design classes, etc. will take in the next period. So, in this period, we will concentrate on three concepts, that is patterns, modularity and information hiding. Patterns. Pattern definition. A pattern is named a jet of insight which conveys the essence of a proven solution to a recurring problem within certain context amidst competing concern. Students, you know the meaning of pattern. Pattern means there is some similarity between the earlier thing and this thing. Okay, so that is why I say it is having similar pattern. But in software engineering, the term pattern is defined as a nugget of insight which conveys the essence of proven solution to a recurring problem within certain contexts amidst competing concerns. So, in software engineering, pattern means a solution, which can be applied to other similar problems. Point number 2. The intent of each design pattern is to provide a description that enables a designer to determine 1. Whether the pattern is applicable to the current work. 2. Whether the pattern can be reused, hence saving the design time. So students, when you are talking about the pattern, so it helps the designer to understand whether the particular pattern is very suitable for the work at present being carried out, that is for the present software which is being developed. Also, when you speak about the pattern, we think of whether the pattern is reuse, that is, can we reuse for some other modules so that we can save the time. And the third aspect is whether the pattern can serve as a guide for developing similar but functionally or structurally different pattern. So, the third point here is that whether one pattern can give rise or birth to one more pattern which is more or less similar. So most important aspect of the pattern is that it will help in modular design and in saving the time. We shall study this design pattern in more details as an independent topic later in this chapter. Students, in this chapter, the last topic is pattern based software design. So there we shall study more regarding pattern. And now we shall proceed to next design concept, that is modularity. So modularity. So students, we develop software in terms of the modules, that is small components of the software are developed independently, and that is what we call as modules. So we'll study in detail. Point number 1. In case of modularity, the software is divided into separately named and addressable components called modules that are integrated to satisfy problem requirement. Students, the modularity is nothing but we divide a software problem into smaller components known as modules which can be independently developed okay, and the solution to these different modules can be integrated to say that it is the solution for the main problem. Point number 2, modular is an attribute of software that allows program to be intellectually manageable. Students, in case of modules, we divide the program into smaller components which can be easily handled, okay, and solution for that smaller components called as module can be independently developed. So modular is an attribute of software that allows program to be intellectually manageable. You know, students, when you divide a problem into smaller problem, it is easily manageable. Point number 3, monolithic software, that is a large program composed of single module, is difficult to grasp by the software engineer. A single program, okay, which is having larger design aspects is difficult to solve. It goes by simple meaning. Point number 4, monolithic software is difficult to understand because of number of control paths, span of reference, number of variables, and overall complexity. Students, you know, when there is a large problem, that is the monolithic software, okay, it has got number of control paths, even the span of the reference is very large, okay, there could be number of lines of the programs, it is very difficult to refer back or refer forward, there are number of variables, and overall complexity increases. That is why instead of having monolithic software, we go for modular software development. Point number 5, it is well known that the difficult problem can be easily solved by adopting divide and conquer strategy. That is, it is easier to solve a complex problem when you break it into manageable pieces. The same idea is true in case of software and modularity, where the main task is divided into subtasks called module. Students, in day-to-day life also, when there is a bigger task, you divide it into smaller subtasks, and we individually distribute this subtask and carry out this subtask. Okay. Similarly, here we can adopt a divide and conquer strategy in case of solving a larger problem. So whatever we divide this big problem into sub problems, these sub problems can be easily manageable, and then we can integrate the solution of the sub problems and say that it is the solution of the main problem. Similar is the case with the software. Okay, these modules are sub parts of the main problem, and these modules can be independently solved, and the solution can be integrated and said that it is the software of the main problem. Point number 6, but the care should be taken that if the number of modules are more, the associated costs of integrating the modules also grows. Yes, if you divide this problem or software problem into smaller modules, number of modules, okay, you should note that at the end of the solution, okay, you have to integrate the solution of every module or every component, and even that will take time. So you should not divide the software into number of modules so that it will create problem at the time of integrating the solution. Point number 7, we modularize a design and the resulting program so that development can be more easily planned, software increments can be defined and delivered, changes can be more easily accommodated, testing and debugging can be conducted more effectively, and a long-term maintenance is easy. So there are a number of advantages if you adopt modularity in the design. Okay, so planning becomes very easy. Even the software development in terms of increment can be defined very easily, module by module, and they can be realized. Also, if you want to change some module, it can be independently changed. You can test the module independently, you can debug the modules independently and it is more efficient. Also, okay, it will help in long term maintenance of the software when modularity is adopted. Now we'll go to next concept, that is information hiding. So we have studied all this case in your object oriented programming. Same concept is true here. Point number 1, the principle of information hiding is to hide the details of the data structures and procedural processing behind a module interface. Okay, so the main idea of this information hiding is to keep aside details or to hide the details of data structure, that is how the data is stored, and procedural processing, that is how the process goes on behind a module interface. Point number 2, knowledge of details need not be known by the users of the module. It is very correct that users need to just use the module. How the modules are developed need not be known. Point number 3, hiding implies that effectively modularity can be achieved by defining a set of independent modules that communicate with one another only that information necessary to achieve software function. Okay, so going for modularity approach hides many details, okay, from one module to another module, and one module can access only required information from other module which is necessary to carry software function. The use of point number 4, continuing our information hiding in point number 4, the use of information hiding as a design criteria for modular system provides benefits, okay, when modifications are required during testing and later during software maintenance. Also, the errors that are likely to be introduced during the modification do not propagate from one module to another. Okay, so student, there are advantages of this modularity in terms of information hiding, that is, okay, we can achieve more, okay, benefits during the testing and during software maintenance. Also, if you go in for information hiding concept, the errors do not propagate from one module to another module. Okay, so today we will stop here as far as this topic is concerned, and tomorrow or in the next period we will take more details. I hope you will write this in your notebook and okay, study it regularly. Thank you.